first, let's mark the square where we want the 1 by 1 piece to end up. Now we're going to add our L shapes one at a time, starting with the largest. And if you think about the largest L shape, there are only 4 positions that we can put this into the square. So we could have the vertex of that L in the top right, or the bottom right, or the bottom left, or the top left. And note that if we add each of the pieces going from the largest to the smallest, every time we've added one piece, we're left with another square. And as long as our marked square is not on the edge of the square that we're looking at, we will always have those 4 choices for how to add the next L shape. So I can add another L shape like this. When we get to the point where the marked square is on the edge of the square that we're looking at, this cuts down our options. Here, the marked square is on the left, and so we can't use the top left or the bottom left arrangements for the next L shape. So we only have 2 options now for how we place the next piece in. I'm going to place it in like this. Once we get to the point where the marked square is in the corner of the square that we're looking at, we now only have 1 option left. So that marked square blocks out anything at the top and anything at the left. And so from then on, we have to add each L shape in a unique way. So we know that we sometimes have 4 options, we sometimes have 2 options, we sometimes have 1 option. And we could start listing lots of different ways of filling this grid and using that fact to try and count the total number of ways. But things are going to get complicated really quickly because of those different numbers of options at different stages. If we knew exactly when the marked square reached a corner, then that would make it a little bit easier. But that's tricky. What we do know, though, is that we can put 2 pieces at the top before the marked square ends up at the top of the square that we're looking at, and we can put 2 pieces to the left, and then the marked square will end up at the left of the square that we remain looking at. And this gives us a different approach. If we write down how we're putting our pieces in, it would look something like this. The first piece might go top right, and then the next piece might go bottom left, and then we might go top left. But we know we can put at most 2 pieces at the top, and so all of the rest of the pieces will have to be bottom something. And we know that we can put at most 2 pieces to the left, and so all the rest will need to be right. And this gives us a totally new way of counting the number of ways that we can do this, because now we're looking at 2 lists. We have got 10 positions in each list, and we know that exactly 2 of them must be top on the top row, and exactly 2 of them must be left on the bottom row. And that means that we have got 10 choose 2 ways of organising the top row, and independently 10 choose 2 ways of organising the bottom row. And 10 choose 2 is 45, so the total number of ways is 45 times 45, which is 2025.